समाचार करेंगे या अभी शुरू करेंगे? शुरू होगा 18 लोग 19 आइए प्लीज। शुरू हो गया। आप स्टार्ट बोल दीजिएगा। Good afternoon to all the participants who have joined me here for a webinar on artificial intelligence. First of all, I would like to thank Atul Bal, our president at IIT Delhi Alumni Association, for making arrangements for this webinar. Artificial intelligence is one of the hottest topics today in the entire world. It is supposed to give us the biggest impact on the economies of different countries, our productivity, the impact that it will have on businesses, manufacturing, as well as services. Looking into the overall scope of artificial intelligence and other connected digital technologies, first I would like to give a broad overview or the big picture of artificial intelligence as to what is happening around the globe. I would like to quote a statement from President of Russia, Vladimir Putin, who has stated last year in a conference that whoever becomes the leader in artificial intelligence will become ruler of the world. This is a very apt statement. The superpowers of the world, led by USA, they are all trying to engage very deeply with artificial intelligence and gain an edge in this technology. If we look at the history of the countries which attained superpower status over the last 3,000 years, we would realize that those countries which had the highest GDP per capita or had the highest amount of prosperity were always leading in the technological domain. To begin with, in the ancient times, China and India were the leaders. They were also leaders in technology. We had so many technologies in the past, in medical field, in shipping, so on and so forth. Now, we have had 3 revolutions in the past. based upon steam, electricity, and computing. For the last 300 years or so, these three revolutions have changed the economic structures of the world. In the computing age, America obviously had the lead. They also grew very strongly in the previous wave of electric revolution. And now we have this fourth revolution, what we call as artificial intelligence. Now, this is based upon the human intelligence, the way our brain works. So what are we trying to do in artificial intelligence? A simple definition to understand what artificial intelligence is all about. The simplest definition we can think of is artificial intelligence is planting human-like intelligence in machines or computers that can perform one or more tasks the way humans do. There are large number of other definitions, but what we really mean, we are trying to implant the working of the human brain system into an artificial system like computers or machines. So this is a very tedious exercise. Our scientists tried it out 6 or 7 decades back. It all started with Turing test designed by a British mathematician in 1950. Later on, Professor McCarthy of Dartmouth College took it forward. In the summer of 1955, he set up a team of 10 scientists, and this team or committee thought that they could cover the whole gamut of artificial intelligence in a 2-month study. However, subsequently, nothing much matured. Governments made huge expenditure without any results. So there was a hue and cry, and the parliamentarians decided to discontinue their investments. What led to, we call it as AI winter. Now, there was a lull for almost 1.5 decades. Then, suddenly, we had certain enablements, technological improvements. By this time, the computing power had vastly improved. The cost of connectivity had come down, and we had other technological capabilities which made it possible to experiment upon artificial intelligence systems once again. Some of the famous scientists of today, they started experimenting upon deep learning, one of the sub-technologies of artificial intelligence, and they found that now with GPUs, graphic processor unit, they could take the experimentation forward. And therefore, the new journey began in 2010. After about a decade, the technology has come to quite a substantial progress. And since 2012, number of solutions have been designed using the technology of artificial intelligence. If we look upon certain parameters which show how the technology has progressed, then we can certainly come to a conclusion that artificial intelligence is right now in almost a bull run. In the next decade, this technology will provide us the backbone of economic and business progress. It is going to impact large segments of every industry conceivable, whether in manufacturing or services. We find that services sector like e-commerce, finance, healthcare, communication are all using artificial intelligence very heavily. Before we go into the definition of what artificial intelligence is all about, I would like to give a small picture about what this intelligence consists of really. As I said, we are talking about artificial intelligence. So how do we distinguish it from our natural intelligence? We know that natural intelligence consists of certain qualities like reasoning, learning, perception, problem solving, cognitive ability, and so on and so forth. We are trying to use some of these capabilities for our machines and computers. This is not to say that we have been successful in transplanting these human capabilities exactly into the machines. In fact, we are just trying to do one or two tasks out of thousands and thousands of tasks that our human brain is capable of doing. So there is a distinction between general AI and narrow AI. So right now, what we are trying to achieve something out of artificial intelligence is narrow AI. That is doing one or two tasks. Whereas general AI is something where machines can do exactly the way humans are able to do their own work. Right now, with the technological capability, we are nowhere the capability of general AI. If we look at a comparison between the best of computers that we have today with the capacity of our brain, there are clear distinctions in terms of, let us say, processing speed. Our human brain is 10 times faster than the best computers we have so far. Our organization of human brain is very efficient. It is a single whole where information is received, processed in one chamber only. Whereas the artificial organization of brain isn't that smooth and isn't that of such high order. Similarly, in terms of calculation and processing power, human brain is much faster. Human brain also has lots of flexibility, and therefore we have logic, predictability, and neuroplasticity. We have qualities like uh, creativity. Now, machines cannot be so creative. Our human brain uses very little power, maximum of 20 watts, whereas a similar type of machine will use something like 10 million watts. Similarly, the weight of the machine would be something like 150 tons against weight of human brain, which is just 1.4 kg. Now, these are some of the distinguishing features of artificial systems and our brain systems. So therefore, artificial systems isn't that capable of something that could be of general AI in character. Now, again, as I said, before we go into the definitions of and sub-technologies of AI, since this is not a session on technology, I would like to present to my participants some of the things that are already happening with the use of AI so that they can have an appreciation of what it is capable of achieving. We have all known about Industry 4.0, where the digital technologies are being deployed for re-architecting the whole manufacturing system. Now, manufacturing floors are becoming much more automated. Robots are being deployed. In fact, Tesla factory is fully roboticized. So manufacturing is going a deep changeover. And related to manufacturing, there are many tasks which are of service-oriented nature. For example, shipping, transportation, receipt of goods and services, documentation. All these processes of services are also going through a process of transformation with the use of the latest digital technologies. Now, if we look at some of the other products, our homes are getting smarter. We have thermostats, remote adapters, automatic power systems, security systems. Now, these are all becoming smart machines. At home, we are also having IoT, Internet of Things, which connects these devices. A time may soon come where homes will be fully digitized, homes will generate lots of data. There are large number of startups which are working on digitization of the homes and making it smarter. We have gadgets like refrigerators, washing machine, all kitchen equipments which are getting smarter. We are having, of course, simplest which we see in large usage today is device like Alexa, Google Assistant, Siri, Cortana. Alexa has a market share of over 60% in this field. Similarly, we have large number of robots which are being used for cooking, for serving, for entertainment for children, for taking care of the elderly. Samsung has gone big on artificial intelligence, where there is a content tailored for the user or the viewer, for example, for smart televisions. Similarly, they have refrigerators. Now, these refrigerators are again smart, where stocking of the goods is tracked properly and it can order for whatever is in short supply. So, if we look at the entire scenario of development of products and services which use artificial intelligence, there is a whole lot of things. Then, of course, at the larger level, we have self-driving cars, we have drones, governments are going for smart city projects. Large number of solutions exist for making the city smart in terms of management of traffic, in terms of waste disposal, in terms of automated parking, and so on and so forth. In the next decade, we will see huge penetration of all of these devices and technologies. So, having given a broad overview of the larger picture and the products and services available, now we would like to look at what this artificial intelligence is all about. So basically, it consists of several sets of sub-technologies. First and foremost is machine learning. There, a subset of machine learning is deep learning or neural network. Then next is speech technology. In speech, we have natural language processing, which converts speech to text or text to speech. Then we have computer vision. Computer vision consists of machine vision and image recognition. Then we have expert systems, robotics, planning and optimization, and so on and so forth. If we look at the simplest of AI technologies, which starts with machine learning involves a lot of things. Basically, first of all, it uses data. So from data, we can get to develop a trained model. So, for example, if we have some data relating to cancer patients, now we want to predict from our future data of patients who are coming for examination as to what is the likelihood that a patient may develop a cancer problem. So from the past data, first of all, we divide the data into two parts. One is training data and second is test data. So with the training data, we will develop a model of possible decision-making rules. We have to set out objective functions. We have to define those objective functions and go for a model training for maximizing that objective function. This way, from the training data, we develop a model based upon algorithm. Now, if we have perfected that model, then we test it on the other set of data tests and make the model more mature. So in this process, a machine learning program has been developed for identification of certain, for example, cancerous tissues. Now, when a patient comes, we can test on this model as to what is the likelihood that patient is likely to contract cancer at a future date. Now, this machine learning can be applied in large number of solutions and services. For example, in retail, it can be deployed for demand forecasting, supply chain optimization, pricing optimization, market segmentation, and making recommendations. Similarly, in finance, machine learning can be used for risk analysis, fraud detection, or simply credit scoring of those who are seeking loans. In marketing, it can be used for making recommendations. It can be used for social media analysis, and so on and so forth. This machine learning has vast application. You name any sector and a machine learning model can be developed for applications which will enhance the functionality of that sector, be it energy, utilities, medical, manufacturing, or even a sector like legal, where legal search, predictive litigation, or e-discovery can be achieved through machine learning program. At the next level, we have deep learning. Deep learning is based upon functioning of the human brain of our neural network. The human brain consists of something like 100 billion neurons with protective cover and 1,000 trillion connections. At the moment, we do not know what type of connections develop in what type of situations. Now, what we are trying to do, that in more complex problems, we are trying to replicate the functioning of our neural network in human brains. And with the use of that system, we have developed deep learning programs where certain inputs can be processed within the neural engine and output can be obtained, which will provide us solutions in more complex situations. Now, deep learning algorithms are of different types. For example, one is deep neural networks, which is providing lift for classification and forecasting models. We have convolutional neural networks where feature extraction and classification of images can be done. With the third type of neural network is recurrent neural network, which is used for sequencing of events, language modeling, time series, etc. The third subset of technology, which is most useful, is computer vision. As I stated, computer vision is of two types: computer vision, machine vision, and embedded vision. If certain applications relating to computer vision are in machines, that is used for certain applications for those machines. Embedded vision, where we have thousands of applications in consumer sector, automotive sector, medical, defense, retail, gaming, security, education, transportation. Now, what is this computer vision all about? Wherever there are images involved, we have to extract from those images certain features, and those features can be used to develop large number of solutions based upon feature extraction from those images. For example, we are having currently software program for monitoring of infrastructure projects. Tomorrow, we can simply capture those images. Say a drone makes a trip to a construction project. Let's say a tall building is being manufactured and there is a proper plan laid out as regards completion of the project. Now, drones can capture images. It can make 2-3 trips in a day and feed it into the system, and we can monitor with the images collected by the drones in real time the progress of those infrastructure projects. Now, computer vision can similarly be applied in industry, deployed from end to end in fill check that there are no foreign elements inside the bottle. Bottle is real, it's not a duplicate. Marks and numbers reflect correctly. Then it goes for filling. This computer vision system will ensure that the fill has been done to the right level. It will go to the next stage for capping, and the computer vision application will ensure that the capping of the bottle has been done properly, and finally it goes out. At any stage, if in the bottling plant there are any defects vis-a-vis the technology, is natural language processing. It is based upon understanding and interpretation of natural language. So from text to speech or speech to text, both can be handled by natural language processing system. Now, there could be a solution where, for example, someone is stating or making a speech in a particular language in English, say, for example. Now, that speech can be simultaneously released in any number of languages. So, the English speech can be released in French, Spanish, Portuguese, Chinese, Hindi, Telugu, whatever language we can think of. Another application of natural language can be indexed. As soon as a lawyer is making a search based upon certain words, whatever cases have been decided in relation to that particular word will immediately come on his screen. Now he can make it even more contextual and go for a deeper search. Now the advantage is that whereas earlier lawyers would spend hundreds of hours in conducting a research on any particular topic, with the use of natural language processing, the whole thing can be done within minutes, saving in huge resources and now, obviously, this natural language processing will have large number of their own examination internally. For example, grammatical checking for syntax. It will have to discover the meaning of the text, which is semantics. Now, similarly, what is the purpose of the text, which is referred to as pragmatics. Then systematic organization of sound in language, which is phonology. And finally, relationship of words with each other, what is called as morphology. Simplest example of this is Alexa. We interact with Alexa in voice. Alexa captures our voice, converts it into answers have been designed for large expressions and so on and so forth. Now, after fetching that information from the system at the back end, it again brings it back in the